Lesson 105, number 28. It wants the 4/4 roots of -1. It wants them in rectangular form, and it wants exact answers. So that might be tricky. The 4th roots of -1. -1 can be written as -1 plus 0i. So the angle, well, the y-coordinate must be 0. And the hypotenuse, or the x-coordinate, is -1. So that's actually, if I put it on if I graph it, it's right there. It's -1, comma 0. Okay, so to put that in polar, I wanted to use de Moivre because I need 4th roots. So put into polar, the angle measure is going to be 180. And the hypotenuse is, or the radius is 1. So that's 1 cis 180. And then we use de Moivre on it. So you're going to take the 4th root of the radius, which is 1, because the 4th root of 1 is 1. And then you're going to divide the angle by 4. 180 divided by 4 is 45. And then you can use this little shortcut. We're looking at 4th roots, so that means I can take 360 divided by 4. That gives me 90. That means these angles are all going to be 90 degrees apart. So I just went 1 cis 45, then I just wrote 1 cis all the way down for 1, 2, 3, 4. The 4/4 roots. And then I just kept adding 90. Okay. So that was like a no-brainer. I just wrote all those down because it's always going to have the same radius, and it's just going to have, it's the same triangle, it's just moving around the it has 90-degree angles in between them. Okay, so how do we get them into rectangular and exact form? So in the past, you've just been able to leave them in polar like this, and it's been fine, but now it's kind of a little bit of a hassle to get them into rectangular. But what you're going to do is, it's kind of like working backwards. You're going to draw a radius of 1 and an angle measure of 45. So I just went over to my unit circle, or homemade unit circle here. And so I drew this triangle, angle measure of 45, radius of 1. Now I need the x-coordinate and the y-coordinate. My hypotenuse is 1. My triangle that I have memorized has the two sides are 1 and the hypotenuse is √2. So I wrote down my memorized special triangle 1, 1, √2. And I'm going to use the fact that they are similar triangles to draw a proportion and use cross products and solve for x. And then I'll solve for y also. So I can say 1 is to x as √2 is to 1, and I wrote that right here. So hypotenuse over x. 1 is to x as √2 is to 1. If you do cross products on there, you get 1 times 1 is 1 equals x √2. Divide both sides by √2, and you get x is 1 over √2. If you rationalize the denominator, you got √2 over 2. So that's the x-coordinate. And then you just do the same exact thing for y. I'm going to say hypotenuse is to opposite as hypotenuse is to opposite. Or in other words, 1 is to y as √2 is to 1. Okay, and then I'm just going to cross products. 1 times 1 is 1, √2 times x, or sorry, √2 times y is √2y. Divide both sides by √2. I got 1 over √2, but I already know that that's √2 over 2. So x and y are both √2 over 2. Okay, those are my rectangular coordinates. I just stick a little eye on the end of the y, and I'm there. So for this 45-degree angle, the x-coordinate was √2 over 2, and the y was √2 over 2, and you have to stick an eye on it. Because we call the y-axis the imaginary axis when we're doing polar. Okay, and then I noticed that the rest of these triangles, they're all like 45-degree triangles. And so all these, I don't have to do all this work over again. I already know what x and y are going to be. They're always going to be √2 over 2. I just have to look at the signs and say, well, okay, X is 135 is in quadrant 2, so X is going to be negative, Y is going to be positive. So I just change the signs around. So I'm kind of taking a shortcut here too. X in quadrant 3, X is negative, so I got negative. Y is also negative. And quadrant 4, positive X, negative Y. And there's your answer. So your answers, really, the ones that it's asking for are these, the rectangular coordinates.